Good day, everybody. And once again, we're back together. This is video number 2 on proving identities for grade 11. So, if you haven't subscribed, please just make sure you're part of the family. All right, so now let's continue. If you have not watched video number 1, where I introduced this section, please just go back and watch that video. All right, now I'm going to be continuing. So I did example 1 and number 2 in that video, but I also gave you the steps to follow whenever you are proving identities. So today I am going to be continuing with number 3, right? So let's start with exercise 3. So we've got cos squared of x divided by 1 plus the sine of x, okay? And they want us to prove that this is equal to 1 minus 10 of x multiplied by cosine of x. Right, now I want us to look at this together. I said to you, the first thing that we do, we always work on the left and the right hand side separately. So I'm going to separate those two sides, okay? So on the left hand side, I've got cos squared divided by 1 plus sine x, right? Now, I want you to notice in this case, on the left hand side, there's really not much that I could change, but I've got an idea for that one. On the right hand side, however, we do have 10 of x, right? So if I look at this, remember I said to you, you convert everything into sine and cos. So I've got 1 minus sine of x divided by cos of x multiplied by cos of x, right? Okay, we can say over 1 if you want to, okay? We know that that is a we are multiplying those two together, right? So what does that do? This cancels that cos of x and cos of x cancel each other out because we are multiplying there. And so what are we left with? We've got 1 minus sine of x. Now, definitely left-hand side does not look anything like the right-hand side. So what can we do on the right-hand side? We've got cos squared. And we want to convert that into something that has sine of x, right? So remember, our square identity, we can convert this into 1 minus sine squared of x. Now keep in mind, we did say that cos squared of any angle plus the sine squared of any of the same angle, this would be equal to 1. So in this case, that's why we were able to convert that cos squared of a into 1 minus sine squared of a, right? So we've written it in that manner. So this would give us divided by 1 plus the sine of x. Now, if you watched the previous video, you'd remember what I said about what looks like what we have at the top. This is the difference of two squares, right? This is the difference of squares. So we can factorize that part as 1 plus sine of x and 1 minus sine of x, right? This is divided by 1 plus sine of x. And what do you know, right? I've got something at the denominator that looks like something we have at the numerator. So those two can cancel each other out. And guess what I'm left with? I'm left with 1 minus sine of x. And what do you note? The left-hand side is equal to the right-hand side. All right, ladies and gents, it's very important when you do these identities that you keep to the rules that I actually have shown you. All right, and we're going to continue with the next one. Okay, so if you look at that, we've got sine of x. In this case, we're given the sine of x, right, divided by 1 plus cosine of x, right? And please, I want you to try it out on your own first before you look at my solution, right? This is plus cos over sine of x, and this is equal to 1 over sine of x. All right, now let's go for it. All right, so, okay. So let's write it down first. So for number 4, and I hope that you paused and watched, or rather, tried the example on your own first. So we've got sine of x divided by 1 plus cos of x this is plus the cos of x divided by the sine of x. And we want to prove that this is equal to 1 over sine of x. Now, let's do that. So we said we work with the left-hand side and the right-hand side. We separate them from each other. There's nothing much we can do on the right-hand side, okay? We already have everything in terms of sine and cos there. And then we don't have any square identities, and nor do we have anything we can convert to sine and cos on the left-hand side. But what can we do? We've got two fractions, right? We've got fractions, and I said to you, whenever you've got fractions, you need to add them together, right? So what is our LCD? Our lowest common denominator would be, right? So I've got two different things there. So this would be 1 plus cos of x multiplied by sine of x. Now what I said to you, whenever we are adding fractions, right? Please remember, what I'm going to do is I'll have the LCD as my denominator. So that's 1 plus cos of x, all right, multiplied by sine of x. Now, you take the LCD and you multiply it into the fraction, right? So I want you to imagine, and I'm going to write this in a different color, right? So I'm going to take that LCD. So I've got sine of x multiplied by 1 plus cos of x. And I multiply it into both my fractions. So again, I've got sine of x into 1 plus cos of x. Remember, I have separated the left and the right hand side, so I'm not going to do that on the right hand side, okay? Right, so I'm doing this on the left only. Now notice in this case, right, what's going to happen, right? So you would cancel this guy and that guy out, and what are you left with? Sine x multiplied by sine x. So you've got sine squared of x. I hope you got that, ladies and gents. I'll say this again. You multiply your LCD, right, to the fraction. And what did we do? We've got this guy, right, similar to that guy, and we can cancel them out. And so whatever is left, we multiply with each other. So sine x times sine x, I've got sine squared of x. I hope that's clear, ladies and gents. Right, I'm going to do the same with the other fraction, okay? Right, so in this case, what cancels out? I've got sine of x cancelling out with sine of x, and now I've got cos of x multiplied by 1 plus cos of x. So I'm going to write that down. So this is plus, this is that sine over there. This is cos x into 1 plus cos of x. Now please have a look at it. So I can multiply out in this case. So I've got sine squared of x plus. Here I'm going to use our distributive law, right? Cos x multiplied by 1. That will give me cos of x. And I've got cos x multiplied by cos x in this case. And that will give me cos squared of x. Now notice, what do we still have? We still have the denominator, which is 1 plus cos x multiplied by the sine of x. I hope you can see what I see there. I can see that I've got sine squared of x plus cos squared of x, and that would give us our square identity, ladies and gents. Right, so in this case, sine squared of any angle plus the cos squared of the same angle will simply give us 1, right? So those two gave us 1, but we still have the cos of x. And so, divided by the denominator, right? In the denominator, we've got 1 plus cos of x multiplied by sine of x. And I hope you can see what happens there, right? If I take this divided by that will give us simply 1, Okay, and so what we ultimately have, we've got 1 over the sine of x. And guess what? We've got left hand side equal to right hand side. And I am going to leave it there, right? We're going to do the next ones on the next video. All right, I hope that you were able to understand, ladies and gents, and please don't forget to subscribe and to like, and we are going to see each other when we continue on this series. See you guys next time. Sharp, sharp.